Hi folks, this is our reflection for lecture 13, September 24th. Today we talked about chapter 5. We talked about, spent a lot of time talking about acid-base neutralization reactions and also redox reactions, in particular assigning redox or oxidation numbers or oxidation states to atoms within a reaction, and using those to determine what it was oxidized and reduced. So with that, I'm going to take a look at your exit ticket and go over it with you so you can help prepare for your quiz on Friday and your homework assignment, which is due tomorrow night. Okay, so looking at this exercise, this one is pretty new to you guys, so I'm not terribly surprised that some of you struggled a bit. Hold on a second. Okay, so we looked at this first exercise and said, what is the oxidation number on copper? So we need to look and think about our rules that we talked about in class today, and this copper is a monatomic ion, so the question is, what is that charge? So if you remember, sulfate is 2 minus, and since you have 2 coppers, this total species must be +1, and so, or the total species copper sulfate here must be neutral. So that means if you have 2 of those, each one must be +1. And so as we recall, the charge on a species, a monatomic species like this, is equal to your oxidation number. So that's why this one was correct. Okay. Alright, so let's move down to this next one. This one, people, I think it looks like most people got this one, but I know some people talked to me about it and were a little confused. And the key with this one is to make sure you get the Lewis structure right. So we call this methylene chloride. HCl, Cl, okay. And then to remember what the electronegativity, and that our chlorines are more electronegative than our carbons more electronegative than our chlorines, than our hydrogens, I mean. And so that means that these chlorines are going to have a -1, and the hydrogens are going to have a +1. And so overall, this whole thing is supposed to be neutral. And so that means that you have 2 minus 2 plus the carbon. You'll see that these cancel each other out, so therefore this one is 0. Okay. Finally, all right, we sort of put it all together with this last question. And in this last one, the question is, what species being reduced in this equation? So we have to look at this. We have to look at the oxidation states on all of our elements. So if we look at the reactants here, carbon, right, has 4 hydrogens to it, and each of these hydrogens, right, and we have 2 oxygens, we have O2. And so if we look, so each hydrogen or carbon is more electronegative than hydrogen, so each hydrogen is going to be +1. And so for this to be neutral, carbon has to be -4. Whoa, okay, it just zoomed in for no apparent reason, huh? Okay, so I don't know what that snafu was, but our carbon is going to be -4 here. Our hydrogen is going to be +1. And our oxygen, since this is the elemental state, this is 0. Alright, so that's the reactant side of the products. If you look at the CO2 here, we did this one in class, and we saw that these oxygens are -2 here, and that the carbon is therefore +4. Alright, so you can see carbon is going from -4 to +4, so therefore carbon is being oxidized, so it's not being reduced. Hydrogen here is going from +1 to, let's look at our water here. Alright, so this is +1, +1, -2, right? So hydrogen is going from +1 to +1, so no change to hydrogen. But you see oxygen is going from 0 to -2, so therefore oxygen being reduced, right? In particular, O2 is being reduced. Alright, so it looks like from your answers here that the most popular choice was O2, but a close second was methane. And so you kind of had a 50-50 shot. And what is actually happening here, remember, is the O2 is the one being reduced. Okay, so again, there's some practice problems like this on your sapling homework, so I'd recommend giving those a look. And I'll help you prepare for the quiz on Friday. So I'll see you all then.